Hello everyone. Today I am presenting my reinforcement learning project titled Warehouse Robot Path Learning using a Q-learning and Streamlit. The main objective of this project is developed an intelligent warehouse robot that can be learn how to navigate through a warehouse development, pick up package, avoid obstacle and successfully deliver the package to this destination. The projects demonstrated how reinforcement learning can be applied to real-world warehouse automation and logistics systems. As we can see on the screen, this application is developed using a Streamlit, which provides an interactive web interface for training and visualization the robot learning process. The warehouse environment is represented as a grid where the robot must move from one location to another while avoiding obstacles. Unlike traditional programming, where every movement is predefined, this robot learns through experience using the Q-learning algorithm. Okay. First, training parameters. On the left side of the screen, we can see four important parameters that control the learning process. The first parameter is a learning rate. The learning rate determines how quickly the robot updates its knowledge after receiving new information from the environment. The second parameter is the discount factor. The discount factor determines the importance of future rewards. A higher value encourages the robot to consider long-term benefits while making a decisions. The third parameter is the acceleration rate. The parameter controls the balance between acceleration and exploitation. Exploration means trying a new path, while exploitation means selecting the base path already learned. The fourth parameter is number of episodes. An episode represents a one complete training attempt. In this project, the robot trained 99 concepts, allowing to gain sufficient experience and improve its performance. Understanding the warehouse environment is now let's understand the warehouse environment. The warehouse consists of several components. The robot started from the initial position and pickup location is defined where the package is available. A delivery location represented by the final destination. There are also obstacles that simulate shields or restricted areas inside the warehouse. The robust The robot must successfully navigate through the warehouse, collected the package, and reach the delivery point while avoiding obstacles. This is similar to the operation of autonomous robots used in the modern warehouses. Reinforced, reinforcement learning concept. This project is based on a reinforcement learning. The reinforcement learning and agents learns by interacting with an environment. In our project, the agent is a warehouse robot. The environment is warehouse grid. The state or the robot position, the action or moving it up, down, left or right. Reward Rewards guide the learning process. Okay, the robots continuously interact with the environment and gradually learns the base strategy. Reward system to encourage efficient behavior, reward system is defined. What the robot reaches a pickup point, it receives a positive rewards. It successfully delivers the package, it receives a large positive rewards. Every normal movement receives a small negative reward to encourage a shorter path. The first robot is an obstacle, it receives a large penalty. Q-learning algorithm is a process using a Q-learning algorithm. Okay. The Q-learning equals this QSA equal to QSA plus alpha equal to maximum value and QS bar and A bar minus QSA. QS is representing current knowledge and alpha is representing a learning rate and theta is a discount rate, R is a reward received, S is a current state and S dash is the next state. Okay, ma'am. Training phase. Okay. The training phase, yeah. The training phase, now I click the training reboot is already training completed. Okay. Initially, the robot has a no knowledge of the warehouse. Okay. Therefore, they explore different routes and randomly. Some routes lead to obstacle and generally penalties. Some routes lead closer to the destination and generated rewards. Okay. Wow. Next one, uh, learning progress graph. Okay. Wow. This is a learning progress graph. After training is completed, a learning progress graph is displayed there. This graph shows how the average rewards changing during the training process. At the beginning, the rewards are relatively low because the robot frequently makes mistake. As training progress, the rewards increase, indicating that the robot
Hello
is learning
everyone.
more
Today I am
efficient
presenting my
navigation strategies.
reinforcement learning
The overall
project
trend of the
titled
graph
Warehouse Robot
demonstrated
Path
successful
Learning
training.
using a
Next one,
Q-learning and
optimal route.
StreamNet. The
Yeah,
main
we
objective
can
of
see
this
the
project is
optimal route
developed
section.
an
This section
intelligent
displays the
warehouse
best
robot
route
that
learned
can be
by the
learned how
robot.
to navigate through a
The route
warehouse
is
development,
represented using a
pick a
coordinator
packet,
that indicated
avoid
the
obstacle,
robot
and
movement through the
successfully deliver
warehouse.
the package to this
This path
destination.
represents the
The
safest and most
projects
efficient route
demonstrated how
discovered during
reinforcement
a
learning can
training.
be
The
applied to
robot
real-world
follows this
warehouse
route to
automation and
maximum rewards
logistics
and
system.
minimize penalties. Next one,
As we
Varos
can see
layout.
on the screen,
The
this
Varos
application
layout
is
section
developed
visually
using the
represents the
StreamNet,
environment.
which provides an
Okay.
interactive
In this
interface
layout,
for
in the
training and
first
visualization.
one
The robot
represents the
learning
robot's
process.
path,
The
and
Varos
minus
environment
one
is
is
represented as a
represented the
grid
obstacles,
where the
and
robot
two is
must
represented by
move
the
from
delivery
one
point,
location to another
and
while
three
avoiding
represented the
obstacles.
pickup point. Okay,
Unlike
this
traditional
visualization
programming where
helps
every movement
use
is
clearly
predefined,
understanding
this
how the
robot
robot
learned
navigating
through
around the
experience using the
obstacles
Q-learning
while
algorithm.
moving it towards its destination.
First, training
Performance
parameters.
analysis.
On the left side of the screen, we can
The
see
performance
four
section displays the
important
success rate
parameters
achieved by
that
the
control the
robot.
learning process.
In this
The first parameter is the
experimental
learning
robot
rate.
achieved
The learning rate
approximately
determines how quickly the robot updates its
69.97%.
knowledge
Okay.
after
The
receiving new
percent
information from the environment.
success.
The second
This
parameter
indicated
is
how
the
often the
discount
robot
factor.
successfully
The discount
completed the
factor
pickup and
determines the
delivery task
importance
during
of
a
future
training.
rewards.
By
A
increasing the
higher
number of
value
episodes
encourages
and
the
fine
robot to
tuning
consider
parameter, the success rate
long-term
can be
benefits
further
while making a
improved.
decision.
Okay.
A third
Next,
parameter
Q
is the
table.
acceleration rate. The
Finally, we can
parameter
see the Q
controls the
table. The
balance
Q table
between
stores the all
acceleration
knowledge
and
learned by the robot.
exploitation.
Each row
Exploration
corresponding
means
to
trying a
state
new
and
patch,
each column
while
corresponding to the
exploration
action.
means selecting the best path
Higher Q
already
values
learned.
indicated a better
The
action.
fourth
This table
parameter
acts
is
as a
number of
robot memory
episodes.
and it helps
An
make the
episode represents
intelligent
one
decision in
complete
the
training
future.
attempt. In the
Okay.
project, the robot
Next,
trained
the
the
real world
1909
application
concept,
used
allowing
in the
to gain
Q-learning
sufficient
algorithm.
experience
The
and
concept
improve its
demonstrated that
performance.
this project can be applied in several
Understanding
real-world
the warehouse
domains.
environment is
This
now
including
let's
smart
understand the warehouse
warehouse
environment. The
logistic
warehouse consists
automation,
several
autonomous delivery
components.
robots, and
The
industrial
robot,
robotics,
the robot started from the
supply chain
initial
optimization.
position
Okay.
and pickup location is different where the
And the
package is
conclusion
available.
is
A
this
delivery
project
location
demonstrated how
represented by the
reinforcement
final
learning and a
destination.
Q-learning algorithm can be used to
There
solve
are also
warehouse
obstacles that
navigation and
simulate
package delivery
shields or
problem. The
restricted
robot
areas
learns
inside
through
the warehouse.
interaction with the
The robot,
environment, receive the
the
rewards and
robot must
penalties,
successfully
update its
navigate through the
knowledge
warehouse,
using a
collected the
Q-learning,
package, and
and
reach the
evenly
delivery point while
discuss an
avoiding
optimal
obstacles.
route.
This
This
project
is similar
highlighted the
to the
practical
application
use
of
of
artificial
autonomous
intelligence
robots
in
used
warehouse
in a modern
automation
warehouses.
and intelligent logistic
Reinforce,
systems. Thank you.
reinforcement learning concept. This project is based on a reinforcement learning. The reinforcement learning and agents learns by interacting with an environment. In our project, the agent is a warehouse robot. The environment is warehouse grid. The state or the robot position. The action or moving it up, down, left, or right. Reward rewards guide the learning process. Okay, the robots continuously interact with the environment and gradually learns the best strategy. Reward system. To encourage efficient behavior, a reward system is defined. What the robot reaches a pickup point, it receives a positive rewards. It successfully delivers the package, it receives a large positive rewards. Every normal movement receives a small negative reward to encourage a shorter path. The first robot hits the obstacle, it receives a large penalty. Q-learning algorithm is a process using a Q-learning algorithm. Okay. The Q-learning equals this QSA equal to QSA plus alpha equal to maximum value and QS bar and A bar minus QSA. QS is representing current knowledge and alpha is representing a learning rate and theta is a discount rate, R is a reward received, S is a current state and S dash is the next state. Okay, ma'am. Training phase. Okay. The training phase, yeah. The training phase, now I click the training reboot is already training completed. Okay, Initially, the robot has a no knowledge of the warehouse. Okay, therefore, they explore different routes and randomly. Some routes lead to obstacle and generally penalties. Some routes lead closer to the destination and generated rewards. Okay, va. Next one, uh, learning progress graph. Okay, va. This is a learning progress graph. After training is completed, a learning progress graph is displayed there. This graph shows how the average rewards changing during the training process. At the beginning, the rewards are relatively low because the robot frequently makes mistake. As training progresses, the rewards increase, indicating that robot is learning more efficient navigation strategies. The overall trend of the graph demonstrated successfully training. Next one, optimal route. Yeah, we can see the optimal route section. This section displays the best route learned by the robot. The route is represented using a coordinator that indicated the robot movement through the warehouse. This path represents the safest and most efficient route discovered during a training. The robot follow this route to maximum rewards and minimize penalties. Next one, warehouse layout. The warehouse layout section visually represents the environment. Okay. In this layout, in the first one represent the robot's path, and minus one is represented the obstacles, and two is represented by the delivery point, and three represented the pickup point. Okay, this visualization helps you clearly understanding how the robot navigating around the obstacles while moving it towards its destination. Performance analysis. The performance section displays the success rate achieved by the robot. In this experiment, the robot achieved approximately 69.97 percentage. Okay, the percent success. This indicated how often the robot successfully completed the pickup and delivery task during a training. By increasing the number of episodes and fine-tuning parameter, the success rate can be further improved. Okay. Yeah. Next, Q table. Finally, we can see the Q table. The Q table stores the all knowledge learned by the robot. Each row corresponding to state and each column correspond to the action. Okay. Higher Q values indicated a better action. This table acts as a robot memory and it helps makes an intelligent decision in the future. Okay. Next, the real world application used in Q-learning algorithm. The concept demonstrated that in this project can be applied in several real-world domains. This including smart warehouse, logistic automation, autonomous delivery robots, and industrial robotics, supply chain optimization. Okay, and the conclusion is this project demonstrates how reinforcement learning and the Q-learning algorithm can be used to solve warehouse navigation and package delivery problem. The robot learns through interaction with the environment, receives the rewards and penalties, updated knowledge using a Q-learning, and evenly discovers an optimal route. This project highlighted the practical use of artificial intelligence in warehouse automation and intelligent logistic systems. Thank you.